Anchors achieve holding power either by hooking into the seabed, or mass, or a combination of the two. Permanent moorings use large masses, commonly a block or slab of concrete, resting on the seabed. Semi-permanent mooring anchors, such as mushroom anchors, and large ship's anchors derive a significant portion of their holding power from their mass, while also hooking or embedding in the bottom. Modern anchors for smaller vessels have metal flukes which hook onto rocks on the bottom or bury themselves in soft seabed. The vessel is attached to the anchor by the rode, also called a cable or a warp. It can be made of rope, chain, or a combination of rope and chain. Holding ground is the area of sea floor which holds an anchor, and thus the attached ship or boat. Different types of anchor are designed to hold in different types of holding ground. Some bottom materials hold better than others. For instance, hard sand holds well, shell very poorly. Holding ground may be fouled with obstacles. An anchorage location may be chosen for its holding ground. In poor holding ground, only the weight of an anchor matters. In good holding ground, it is able to dig in, and the holding power can be significantly higher. An anchor is a device, normally made of metal, used to secure a vessel to the bed of a body of water to prevent the craft from drifting due to wind or current. Permanent anchors are used in the creation of a mooring, and are rarely moved. A specialist service is normally needed to move or maintain them. Vessels carry one or more temporary anchors, which may be of different designs and weights. A sea anchor is a drag device, not in contact with the seabed, used to minimize drift of a vessel relative to the water. A drogue is a drag device used to slow or help steer a vessel running before a storm in a following or overtaking sea, or when crossing a bar in a breaking sea. The earliest anchors were probably rocks, and many rock anchors have been found dating from at least the Bronze Age. Pre-European Maori waka used one or more hollowed stones, tied with flax ropes, as anchors. Many modern moorings still rely on a large rock as the primary element of their design. However, using pure mass to resist the forces of a storm only works well as a permanent mooring. A large enough rock would be nearly impossible to move to a new location. The ancient Greeks used baskets of stones, large sacks filled with sand, and wooden logs filled with lead. According to Apollonius Rhodius and Stephen of Byzantium, anchors were formed of stone, and Athenaeus states that they were also sometimes made of wood. Such anchors held the vessel merely by their weight and by their friction along the bottom. Iron was afterwards introduced for the construction of anchors, and an improvement was made by forming them with teeth, or flukes, to fasten themselves into the bottom. This is the iconic anchor shape most familiar to non-sailors. This form has been used since antiquity. The Roman Nemi ships of the 1st century AD used this form. The Viking Ladby ship, probably 10th century, used a fluked anchor of this type, made entirely of iron. The Admiralty pattern anchor, or simply, Admiralty, also known as a fisherman, consists of a central shank with a ring or shackle for attaching the rode, the rope, chain, or cable connecting the ship and the anchor. At the other end of the shank there are two arms, carrying the flukes, while the stock is mounted to the shackle end, at 90 degrees to the arms. When the anchor lands on the bottom, it will generally fall over with the arms parallel to the seabed. As a strain comes onto the rope, the stock will dig into the bottom, canting the anchor until one of the flukes catches and digs into the bottom. The Admiralty anchor is an entirely independent reinvention of a classical design, as seen in one of the Nemi ship anchors. This basic design remained unchanged for centuries, with the most significant changes being to the overall proportions, and a move from stocks made of wood to iron stocks in the late 1830s and early 1840s. Since one fluke always protrudes up from the set anchor, there is a great tendency of the rode to foul the anchor as the vessel swings due to wind or current shifts. When this happens, the anchor may be pulled out of the bottom, and in some cases may need to be hauled up to be reset. In the mid-19th century, numerous modifications were attempted to alleviate these problems, as well as improve holding power, including one-armed mooring anchors. The most successful of these patent anchors, the Trotman anchor, introduced a pivot at the center of the crown where the arms join the shank, allowing the idle upper arm to fold against the shank. When deployed, the lower arm may fold against the shank, tilting the tip of the fluke upwards, so each fluke has a tripping palm at its base, to hook on the bottom as the folded arm drags along the seabed, which unfolds the downward-oriented arm until the tip of the fluke can engage the bottom. Handling and storage of these anchors requires special equipment and procedures. Once the anchor is hauled up to the hawsepipe, the ring end is hoisted up to the end of a timber projecting from the bow known as the cathead. The crown of the anchor is then hauled up with a heavy tackle until one fluke can be hooked over the rail. This is known as catting and fishing the anchor. Before dropping the anchor, the fishing process is reversed, and the anchor is dropped from the end of the cathead. The stockless anchor, patented in England in 1821, represented the first significant departure in anchor design in centuries. Though their holding power to weight ratio is significantly lower than Admiralty pattern anchors, their ease of handling and stowage aboard large ships led to almost universal adoption. In contrast to the elaborate stowage procedures for earlier anchors, stockless anchors are simply hauled up until they rest with the shank inside the hawsepipes, and the flukes against the hull or inside a recess in the hull. While there are numerous variations, stockless anchors consist of a set of heavy flukes connected by a pivot or ball and socket joint to a shank. Cast into the crown of the anchor is a set of tripping palms, projections that drag on the bottom, forcing the main flukes to dig in. The basic anchoring consists of determining the location, dropping the anchor, laying out the scope, setting the hook, and assessing where the vessel ends up. The ship will seek a location which is sufficiently protected, has suitable holding ground, enough depth at low tide and enough room for the boat to swing. The location to drop the anchor should be approached from downwind or down current, whichever is stronger. As the chosen spot is approached, the vessel should be stopped or even beginning to drift back. The anchor should initially be lowered quickly but under control until it is on the bottom. The vessel should continue to drift back, and the cable should be veered out under control, slowly, so it will be relatively straight. Once the desired scope is laid out, the vessel should be gently forced astern, usually using the auxiliary motor but possibly by backing a sail. A hand on the anchor line may telegraph a series of jerks and jolts, indicating the anchor is dragging, or a smooth tension indicative of digging in. As the anchor begins to dig in and resist backward force, the engine may be throttled up to get a thorough set. If the anchor continues to drag, or sets after having dragged too far, it should be retrieved and moved back to the desired position or another location chosen.